starting the stream again. Stream preview, learning Lambda calculus. All right, so I'm streaming again. Now we are learning Lambda calculus. I'm streaming again. Yeah, what I mean is I've just stopped one stream and now I'm continuing again. I wanted to, this is kind of a little loud for me. Yeah, like this. It's somehow, this has been a place where I'm stuck a bit. I had a pause. So I already made like 15 videos of learning Lambda calculus, which is pretty long. And it's been fun. But there's been a conceptual, like, it's certain kind of abstraction, rooftop has been reached. Because all of these abstractions so far had a, let's go to Nick's REPL. So again, I'm using Nick's REPL to, which is a very nice way. I'm using Nick's REPL to write Lambda expressions. So like x, 2, this is 2, and this, I repeat this every single time. So, and let's just define the stuff. Let's define the stuff that we will be needing. So this conceptual leap, the last thing what was pretty clear was the select first. Select first, which was a function, right, that selects first. You give it two things, A and B, and it selects the first thing. Then we have the select second, A, B, and it selects the second thing. We had like a little, not a party, more like a friends gathering, and I was actually showing to my two friends, to my wife and a friend anyway, but I was showing them Lambda calculus. They're not programmers, or they don't you know, it's something what they've and of course they didn't have the best experience in school with math and stuff, also because of the teachers, right? But it was very hard to even to begin to explain. Like someone said, so what's a lambda? Why a lambda? You know, and why the head? What do you mean the head? It was very, I was very bad at it, you know. Okay, so we have select first and hello next, and it selects the first, and second, hello next, and it selects the second. And then we had the cond. And then we had the cond. We did the cond, which was basically, you see, I almost forgot. What was the cond? So the select first will basically be our true. Select first equals true, right? Undefined variable true. Oh, this is interesting. I cannot do, yeah, I'm redefining select first. No. True equals select first. So ordering does matter. This is interesting. So select first is true. It's not the same as true is select first. Okay, and false. False is select second. So we do true, true, false, we get true, right? And we do false, false, we get false. Of course, if you do false, true, you get false. And then we did the make pair. The make pair function. The make pair function, that's the thing that makes a pair. A function that makes a pair, but not like a list or like something. It just makes a pair. It makes a promise that it will make a pair, but it needs a function that will do something to it. So we have okay, you have a thing, you have a second thing, and then you have a function, right? And it will apply this function to those two things and create a pair, right? So but it will not, like, if you do just this, make pair hello Nix, right? And you think you will get a hello Nix together, it's not, no, it's not true. I mean, it's not true in the sense that it needs a function that would add them. I don't know, this probably wouldn't work. Wait, hello Nix. Will this work? No. Yeah, I'm doing something like 1, 2, and plus. Look at this. No. Because we use the example make pair hello Nix, and then we use select first, and we got the hello. And these are the substitution rules. Yeah, there is a, like, if you don't know what are the substitutions, how they work, it's very hard to understand what's going on here. So the make pair makes this thing. How does it make a pair, right? We did the, just open up a new tab. We did notes. Am I here? Where am I? ls code lambda. Okay, vim notes. So we were doing this, make pair first and second, select first. So first, like hello, and second Nix. Select first. So we expand, so the function name make pair, we substitute the function definition, right? A, B, F, F, A, B. FST, so first and second, and select first. And then the evaluation goes right here. We substitute the first, or the hello in our case, with the head A. We remove the head here and we put it here in the A. So we get B, F, F, FST, B. So we get FST. And then we have the second and select first. And then we substitute the same thing. Second, we put it inside of B, right? And we remove the B head because we don't need it. And now we have F, F, FST, SND. Now we have a placeholder here for the function and the head. Now we will use this select first, which is a function, which we defined, and we will put it here and remove the head. So now we have select first, or true in our case, right? True in our case, right? So you can look this FST, SND, you see? We get FST when we do true. True is select first. So now select first, FST, SND, we expand select first, A, what is true? True is select first. But select first is something that selects first from two things. True is also something from two things selects the first thing. I guess the confusing thing is what David Beasley was also saying in his Lambda course, that you don't expect true to be just the thing that picks the first thing out of two things, right? Because it makes it, what's the difference between false then, A, B, A, FST, SND, and now FST goes inside of A here. We substitute it for A. We remove the head A. We have B, FST, SND. And now SND does not have anywhere to go, which means we discard it, right? We discard B and we get FST. So this is what I've been going through already a couple of times. But now and then I was stuck. So I'll just read again here and okay. I'll just read again here now. Truth values and conditional expressions. So Boolean logic. Boolean logic is based on the truth values true and false with logical operations not and or. So we're going to define not, and or. That was actually confusing. Not was very confusing at first. Even though conceptually is very simple, right? Not true is false, and that's it. But when you have to define it, it was very confusing. We're going to represent true by select first and false by select second. Right, we did that. And use a version of make pair to build logical operations. So he's going to build a cont now, actually, which is make pair, right? So this is where things get messy, because we are constantly redefining things. To motivate this, consider the C conditional expression. Condition, expression, expression. If the condition is true, then the first expression is selected for evaluation, and if the condition is false, then the second expression is selected for evaluation, which is just a long way to say, you know, if the first thing is true, yeah, if the condition is true, then the first expression is selected. And the condition, well, I guess there is a subtle difference in saying if the thing is true, if the first thing is true, then the first is selected. That's the thing with functional programming. It's really important how you name, how you talk about evaluations. I've been trying to learn functional programming for many years, and it's like it's a language. If the condition is true, then the first expression is selected for evaluation, which is our select first, right? Select first, next, true, false. If this is true, this just selects the first, right? If the condition is true, then the first expression is selected. Maybe this will be a more like a compound kind of a function that will really check something and then use the select first to select first. For example, to set max to the greater of x and y. Max is what? X greater than y. If that condition is true, then select first. Otherwise, okay. So this is some kind of pseudo code, I guess you could say, right? So max if x is greater than y. Or set ABSX to the absolute value of x. ABSX is if x is, I'm kind of cold. ABSX, if x is less than 0, then minus x. Okay, otherwise x. Yeah, it's just, these things are really simple when you just read them like this. We can model a conditional expression using a version of the make pair function. Okay, now again the cont. I already did this in last 2 videos. We can model a conditional expression using a version of the make pair. Now he's saying a version, but this is the same make pair. He's just using different names. So cont is just the same as make pair. So we could basically, as we just said, select first, true is select first. We could say cont is make pair. Although he's saying, you see, we said lambda A, lambda B, like lambda A, lambda B, lambda F. And then I said FAB. So here we see well, okay, here we just see, oh, wait a second. We don't have to write this, right? This is kind of the way functional application works in Haskell or in Lambda calculus, right? That's why it's like you only use white space. So you apply this thing to this thing, and then this entire thing is applied to this thing. right? So it's not like this thing is being, like C is not being applied to E1 and E2. It's applied to E1 and then the whole thing is applied to E2. Why? Because of currying. Because of currying, right? Because we have one function that takes one argument, and that's why this being applied to this and being applied to that. But if you want to see it, you can put these things, you can put the parentheses around this and then around this, so you kind of get this a visual representation. But actually, if you don't write them, you just write C, E1, E2, it kind of implies. This implies, but it's written here just to make it easier to understand. So this is the same as the make pair function. So we could even just do cond equals make pair. And now instead of make pair select first and select second, we have cond true and false. And we reused what we already knew, but it's incredible, right? But when you first do the make pair, you don't see it as cond, and when you make select first, you don't see it as true. You have to be introduced to true to redefine it as select first. So it's kind of nice. I mean, it'd be nice if children learn this in school. They don't learn this in school. Yeah, I don't know how would you introduce this in school. We can model, I guess that's why I'm making this so slow. We can model a conditional expression. Okay, so consider cond applied to an arbitrary expression, expression 1 and expression 2. Right, just as we had make pair. So you could look at this, cond nix. What do we use? Hello nix. And we're going to add a lambda string, but it will be, look at this, cond hello nix and true. We're going to get the same thing as we did with make pair, hello nix, select first. Cond hello nix true will give us hello. And cond hello nix false will give us nix. Isn't this amazing? Consider cond applied to an arbitrary expression 1, expression 2. Now he's going to show us the substitution, how it goes. Right, that's what we did actually. The substitution is what this make pair FST SND select first. That's it actually. That's what he's showing here. That's what he's showing here, but instead of make pair, you just put cond, and select first, you put true. And all of these things apply. Because once you change the name, you get the same thing here. He's not using the ABFFAB, but he's using E1, E2, and C E1, E2. Now, if this function is applied to select first, that's what we get here. Select first, expression 1, expression 2, right? Select first goes here. You see this? Select first goes here, FST, SND. Select first goes here, expression 1. It picks the FST, expression 1. And if it's applied to select second, it's the same thing. It's the same thing. You're just going to get, instead of select first, select second here. And then the first one is going to be discarded because there will be no A, right? Because select second takes an A and a B and gives back a B, not A. Now notice that the condition is the last argument for cond, not the first. I still don't understand what he means by this. Notice that the condition is the last argument for cond, not the first. I still don't understand this. I didn't understand this the first time I read it. I didn't understand it the second time I read it. Notice that the condition is the last argument for cond, not the first. This is a confusing sentence. What is the last argument for cond? Yeah, this is confusing. Now we will use the conditional expression and cond function with def true. Now he's doing what we did, true select first, false select second, to model some of the logical operators. Now he's using the true and false to define not, to model some of the logical operators. Okay, now I'm back at the start actually. I did this 2 previous videos. And now I'm again here. Okay, so not is a unary operator of the form, not something. I guess the unary operator means it takes one operand. That's why it's called unary. Takes not, like it will take true or false, not, well, yes, of course, it would take 2, it would be a binary operator. Yeah. Which we will describe through a truth table with x standing for the single operand. X false, not x true. So this is very simple. Like most people, I think, can understand this. Because we even say it, not true. It means false. I guess people will be confused if you write not true. What does that mean? Not true means, it means true, right? Not true is false and not false is true. So not true, it means true. Yeah, that's the nickname of the, I was doing the stream, the previous stream, and Arnos Spivak, who's in Twig, I saw his nickname is not Arno. Maybe they could be a joke with knock knock, you know, who's there? Yeah, I don't know. Not who's there? What would you, yeah, you have to write something. Yeah, it won't work, that joke. Not something. Not who's there? True. No, it won't. Okay, note that if the operand is true, then the answer is false. And if the operand is false, then the answer is true. Thus, not could be written using a conditional expression as, yeah, I didn't want to, you see, I didn't want to look at the definition of not, and I couldn't define it on my own, which means I'm not creative. You know, the thing I think the goal is to become creative with making all of these functions on your own, but maybe that's too soon. Note that if the operand is true, then the answer is false. And if the operand is false, then the answer is true. So thus, not could be written as a conditional expression as x, the condition, false, true. Yeah. We can describe this using selectors. So if the operand is true, then false if selected. And if the operand is false, then true is selected. This suggests using this. This is what I didn't know. And this is the way to build abstractions in Lambda calculus. So there is a certain kind of thing here, but outside of it, there is the lambda x and the x. And this is the argument that we will provide to the not. So there is some kind of definition inside that will, you know, do something. And the way, yeah. Sorry. So maybe let's try to write not. How would you do not? Lambda x, cond false true x. That's the definition of not, actually. Not is, look at this, lambda x, I'll write it like this in x, cond, false, true, x. I think we can even use this here. Not is lambda x, con, because we already defined it, false. Why did it start with, you see, this is still hard to parse, and x. This is the not. So if I just, let's say I give it true. This wouldn't work, of course. Not true. Let's do it like this. Oh, not. Yeah, let's do it like before. Cond, hello, nix, not. Now, if we do true, we get a hello. But if we do not, we let's do not true. Yeah, I don't know how to test it. This is incredible. This will take a while. Simplifying the inner body gives cond false true x. Oh, again, I have to do this. This is amazing. I feel like this reading this will take like a year or 2 years even. That's the thing with Lambda calculus. Like the videos are so short. I mean, at least what I found, people explain this well, and probably they understand it way better than I. But it's like some of these Lambda calculus videos are explained like, oh, you do this, you do that, and you do this, and you do this, and they make like they show a basic example. But if you really want to build on it, it's just hard. And in books also, they usually show a brief. Yeah. So cond. Why is the head removed now here? Simplifying the inner body gives. Oh. Why is this thing removed? Actually, ChatGPT is good for Lambda stuff. That I found that out. ChatGPT regenerates. Let's make a new list. Can you show the evaluation? Mica. Šta je bilo? Ćeš na stolicu? Can you show the evaluation steps? Let's assume cond is defined as, yeah, which evaluates to A. Yes, this is all correct. So ChatGPT is good for, like, to show you the steps. There are certain programs, I think called steppers or something. They show the evaluation steps, the intermediate evaluation steps. Not cond false true x. Expand cond with its definition. Okay, why is substitute x and not? Oh, that's why not x. Yeah, but this is, why did he use the same thing? Did he use expand cond with its definition? Lambda p, apply cond to false. Apply the result to true. Substitute false with its definition. Simplifying the inner application. Apply the outermost function to x, x. I don't get it. Where or why did he drop the lambda head at the beginning? I see where the confusion arises. The lambda head in the definition is not dropped arbitrarily. It remains part of the function definition until the function is applied to an argument. Here, not is defined as a function of x. So the outermost lambda x stays in place until we decided to apply the function not to an argument. When simplifying the body of the lambda function, we work step by step on the inner expression. Yeah, we expand the cond, which is like our make pair function. We substitute cond into the expression lambda x, cond false true. Why did he use false here? I guess that's the way. Yes, if you... of course. Okay, look at this. Select first. I was just thinking something. Okay, look at this. You have make pair. Hello, let's do true and false. And do select first. So make pair true false select first gives us true, which is the true function. What if you want to get false if I give it true? So that's why it has first false and then true in the definition. So then when you do select first, it gives you false. So you change the order of the arguments here, so that the true, which is select first, gives you false, right? We rename select first into false. So that means cond, false, true, and true, you get false. So that means false. So that would, yeah, there's something about this actually. There's something about this. Cond false true x. So he's expanding the definition. Look at this. And then putting false true x. Now he's substituting E1 with false. That's what we just did. And then substituting true with E2. That's what we did. And then you have the lambda c false true x. And then substituting the function with x. And then, so we will use def not lambda x. Oh, def not is lambda x. X false true. Not true. But why does not true doesn't work now? It's false. Maybe because we didn't give it any value. Maybe it will work like, maybe it will work not true, hello, next. Yes. Not false, hello. So we have true hello. Look at this. True and false gives us true, right? False, true, false gives us false. Not true, true, false gives us false. Not false, true, false, not false. I forgot. Gives us not false, gives us true. Okay, I understand a little bit more now. But this will probably be like for anyone who's watching the stream. This will not be, I don't even think somebody is actually watching. There is one viewer. I think that's me actually. I'm not sure how Twitch one viewer. Yeah. This will probably be hard to understand. There comes a point when you learn stuff like this where you have to move along. You know, some things are maybe not clear at first, but it will become clear later. Right? What do you think? And not false. He shows the not false, which corresponds to the truth table and is a binary operator of the form. And now there is an and. And this will be enough for today, actually. This will be enough for today. How long? 36 minutes, which is fine. It's important to do a little bit by bit with this lambda calculus. It's very nice, but it's kind of, maybe some kind of visual representation would help. Yeah, anyway, that's it for now. Bye.